Hello everyone, this is Group 12's final for ECE 3300. My name is Sherwin and my partner is Jason, and I'll just be giving a software demo of our final project, which is a mini personal computer. So like a computer in real life, our project has like just different kinds of features that a computer would have. For example, we have a stopwatch, a screensaver, a text editor, and a game, a Pong game. And this is the top file which instantiates all these different features. And as you can see, there's a lot of registers and wires, and this is mainly used to establish the connections um, between all these different features and the VGA and the UART and the clocks as well. So here we go. So this is the VGA output logic that we have for the text editor, screensaver, or the Pong game. Depending on the if statement, it'll go to one of these. So reset T, that's the text editor, S is screensaver, and then G is Pong game. So to start off, we have the clock divider code. So the input for this clock wizard is 100 megahertz, and there's two outputs. One is 25 megahertz, and another is 50 megahertz, and they are used accordingly to the different features. So for example, the stopwatch here, it takes in 50 megahertz. And then part of the stopwatch as well is there's a mux for the 7 seg. And then here we have UART, and then we have just more instantiations generally along with the Pong game. We're just establishing connections to the VGA and what we want to happen internally with the game, and also with the screensaver and text editor as well, just mainly establishing connections. And then we have some more logic here that basically connects what we're typing onto the keyboard to the VGA output. So basically with the stopwatch, actually with the stopwatch it's not VGA, we're just connecting this to the FPGA, sorry. So with the stopwatch, whatever key we press, we're using ASCII here so that we can connect the keyboard to the FPGA and control the stopwatch, basically. And then this accounts for different dimensions of the stopwatch for displaying the time on teraterm, which we're using to type all these commands for the stopwatch, as well as we're using it to type for the text editor as well. So let's go to the stopwatch code. So here the main part of the stopwatch code is here. So we're just accounting for different corner cases, normal corner cases that come with the stopwatch, and we're accounting for this through the use of if statements here. And then we have concatenation here at the end to assign the different outputs as well. And then for the sake of time, I'll try and go a little more quickly, but with the Pong game, we have these walls so that we can control where the ball is going. And we already have a ball pattern, because obviously, as you know, with Pong games, the ball typically travels in diagonal direction, so we have to account for that with the walls here, with assigning the walls. So then we have more logic for the ball bouncing, and then we have logic for the bar as well. So this is just to control all the different logic for the bar and the ball. And then this is for the display, from connecting everything to the VGA onto the display. So this is the logic for the display. So now for the screensaver. So with the screensaver, we wanted to have a preset message, so we use an array, and with ASCII, we're able to set a preset message, which is hello 3300 class. And yeah, so that's basically the preset message that we have. And then yeah, so we have a counter here, and that's basically to account for the speed. So depending on the switches, the speed can change. And the same thing as well, the font can change, the size can change depending on the switches as well. So we used even more if statements here to account for the size as well. And yeah, so at the end here we have the bouncers, and that makes it so that whenever we use the switch, we would have to go up and down for a change to be registered from the FPGA board to the display. Okay, and then this is the code for the text editor, and what we have here is that we just have different cases for when the ASCII of inner is put in, it will go to a new line. And then if the ASCII for backspace is there, then it'll just do what a normal backspace would do. And then after 80 characters, we have it so that it goes to a new line. So yeah, just general conventions of a text editor, just to make sure that we account for all the different corner cases. That is the purpose of this very code. And yeah, we just go even more further into different corner cases, and storage, and making sure that different things can be typed on different lines. And then we have the use of UART here, and then more code is instantiated to assure that no corner cases will be an issue. And then we have general UART here, and the reason we have UART is so that besides what's on the XDC file, we can use even more I/O ports. So yeah, that is the whole purpose of UART. So we can use more than what the FPGA can offer. And we have a baud generator here, and this is basically just free running counters that generate an internal clock. And then we have FIFOs here, which are meant for just storing memory. So we have two FIFOs here for that. And the VGA core, what we do here is we basically set the parameters for the monitor for the different borders for the horizontal and the vertical display. So yeah, we're just setting different counters, and then we're setting the parameters for the display. And yeah, that's basically the project. So just to recap, our project contains a stopwatch, a screensaver, a text editor, and a Pong game. And our code, just basically implements all of this. So yeah, thank you.
Hello, this is the final project hardware demonstration for Group 12 for ECE 3300 lecture. My name is Jason Huynh, and my partner is Sherwin Satish. So our final project is a mini personal computer, a mini PC. Our idea behind this project was to implement some features that we do on personal computers onto an FPGA. So for a mini personal computer, we decided that 4 features would be enough. We have a stopwatch, a video game, a text editor, and a screensaver. In real life, people use personal computers for these various features. So we use all the requirements. This final project, we're going to have buttons, switches, LEDs, 7/7 displays, UART, and VGA here, which is connected to this monitor. So I'm going to demonstrate our first feature of our mini PC, the stopwatch. So the stopwatch is controlled using UART. I will use TeraTerm for serial port communications. So by using TeraTerm, we can send data to the FPGA using the keyboard through UART communication. So actually, let me open up TeraTerm. So here's TeraTerm right here, TeraTerm. Now I'm just gonna go ahead and show our baud rate real quick, which is 19,200, as we can see. Okay, so I'm gonna move the FPGA closer to the keyboard so we can see. All right, so to enable the stopwatch, we actually have to flip the switch to enable the stopwatch. We can see the LED turns on, indicating the stopwatch is on. And we can see that the 7/7 displays here show our time elapsed for the stopwatch. Okay, so to start the stopwatch, we use the keyboard here. So we can see TeraTerm is up here. So if I want to start the stopwatch, I hit the letter G for go. So if I press G, we can see our stopwatch start counting. I'm gonna let it count up to 10, and I'll show that we can pause it. Okay, so we can pause the stopwatch using the letter P. So if I hit P, it'll pause. If I press G again, it'll go. If I press P, it'll pause. Now, if we want to transmit the time here, 16.2 seconds, onto TeraTerm, we actually hit the letter R. So if we hit the R, you can see 0.16.2. Which is what it shows here. The time elapsed was 16.2 seconds. So we hit the letter R. I'm gonna show it one more time. We can see 0.16.2. Okay, so if we hit G, it'll go again. If we hit P, it'll pause. Now, if we want to clear the stopwatch, all we have to do is just hit the letter C. See, C, and then it'll clear the stopwatch. We press G, it'll go. We press P, it'll pause. Now, if we hit R, it'll transmit. See, it says right here, 4.3 seconds. If we hit the letter R, we'll see that 0.04.3 seconds will show up right here. Hit R one more time, 4.3 seconds. So if I hit G, it'll go. If I hit P, it'll pause. If I hit C, it'll clear. Now if I clear while it's running, it'll go back to 0, but it'll keep on running, of course. So you can see, so let's just go ahead and pause it and clear. Okay, so that was our UART controlled stopwatch. That was our first feature of our mini PC. Okay, let's go ahead and turn the stopwatch off by flipping the switch down. LED turns off, indicating the stopwatch is off. Okay, so now let's go on to our second feature, which is our video games, which is this switch. So our video game is a one-player Pong game. So if I flip the switch here, let's go ahead and flip the switch, LED turns on, indicating that the video game is on. So here's our monitor. We can see it's a one-player Pong game. And we use these two buttons here to move the paddle. So as we can see, actually it's hard to show both, but this button here will move the paddle down. This button here will move the paddle up. As we can see. Okay, so it's kind of hard to show, but I'm just moving the paddle up and down. Now let's go ahead and just restart the game. If we hit the middle button, it actually restarts the game. So I'm gonna hit the middle button. We can see that the game restarts, as you can see. Hit the middle button. It'll reset the game. Hit it one more time just to show it's the middle button that resets the game. So let's go ahead and play the video game here. Let's reset. Okay. Oh, I missed it there. But yeah, we're just pretty much trying to break the walls on the left there, which is the breakout Pong game. There we go. You see if we break all of those walls, we can just hit the middle button to reset the game, play again. We use the buttons here to move the paddle. You can see. There we go. And there we go. This is our one-player Pong game. Again, just to show that we can reset the game. See, that button resets it. Okay, so that was our second feature of our mini PC video game, because obviously people use PCs to play video games. Okay, so if we flip the switch off, the video game will turn off. You can see, I'm gonna flip it off. You can see our video game turns off. So now to our third feature, which is a text editor, because people use personal computers to write reports or whatever it may be, right? So if we flip this third switch here, which starts up our text editor, LED turns on, indicating that our text editor is on. So you can see we actually have a underlined cursor there, just like a real life, just like a text editor that we always use to show where the cursor is and to show where our letter will end up. So again, we use UART and VGA for this text editor. We use Terraterm to send data using our keyboard through UART communication. So as we can see, Terraterm is up here. Terraterm's still up. Oh, whoops. Okay, if I press enter, here I'm gonna show, it's kind of hard to show both. If I press enter here, you can see we move down. So you can see if we press space, you can see our cursor move. If we press backspace here, it moves back. Okay, now let's actually type some text. So actually I'm gonna do, it's kind of hard to do with one hand, but I'm just gonna do cap locks here. Let's do it like a title. So let's do ECE 3300 final project. Oh, I messed up. Okay. So yeah, backspace does work, as you just saw there. So actually I'll show that backspace works. Let's go to a new line. So let's say you messed up. I'm gonna turn off cap lock. Let's say, I don't know, you messed up, right? Now let's use backspace here. You can see, cleans that all up. I'm also gonna show that special characters work. So if I hit shift, I'm gonna hold shift here. Let's hit those there, and let's hold shift again. Let's hit these up here just to show that special characters do show up, as you can see right there. Now let's go ahead and clear that all up. Now let's go ahead and press cap locks again. Let's put group 12, Jason, and Sherwin. So you can see, now let's go ahead and move to the next line. I don't know, I'm gonna turn off cap locks. Let's do hello. Oh, I messed up, sorry. Okay, world. So you can see, this is just our text editor. We're very familiar with this, and let's type hello everyone. I messed up. Okay. All right, that was our text editor using UART and VGA here. Okay, so that was our third feature. Now let's go ahead and move on to our fourth feature. So this switch here is going to turn off the text editor here. So if I flip the switch off, LED turns off, indicating that the text editor is off. Now let's move on to our fourth feature, which is using this switch here. Our fourth feature is going to be a screensaver. So if we hit this switch on, we can see that the RGB LEDs turn on as well, that what I call an RGB light show, a light show. So if we look at our VGA monitor, we can see our screensaver, which displays a message called Hello 3300 class, because we are going to demonstrate this in person. So I wanted to put a message, Hello 3300 class. So these four switches here, so that switch was used to start the screensaver. Now, if I want to change how fast the message goes, we use these two switches. These two switches control the speed of the message, and these two switches control how large the message is, how large the characters are. So I'm going to go ahead and show that we can make the characters smaller. So you can see using that switch there. Now, if it's already at its smallest, it'll roll over. So as you can see, this switch here makes it smaller. This switch here will make it larger. You can see. So let's go ahead and make it a normal size. Let's go back to this is a good size. Now those two switches there were used to control the size of the message, the characters. Now these two switches here control the speed. So if I want to make it slower, let's say it's too fast, so let's make it slower. So you can see that switch there makes it slower. Let's make it slower one more time. You can see now it's very slow. Now if it's already at slowest and you hit the slow, it'll move really fast, as you can see. Now let's go ahead and make it slower. That was way too fast. Okay, so originally these were supposed to be buttons, but the buttons were used by the Pong game. So we used the switches here just to control the speed and the size of the message. So let's go ahead and speed it up with this switch. Here, this switch here speeds it up. As you can see, if it's already at its highest speed and you hit the increased speed, it will just roll over and go to the slowest speed. So as you can see, this switch here controls the speed. As you can see, these two switches here control the size. So let's make it bigger. Now let's go ahead and make it smaller. So yeah, that was our fourth feature, which was our screensaver. So yeah, those were all four features. We used all the requirements. So yeah, that was our final project, our mini personal computer. Thanks for watching.